Alright, so for this video, we are going to discuss May-June 2022 paper 3, which is pure maths 3 lah, and then the variant paper 3-1. Alright, so let's start with question number 1. Okay, so for question number 1, we want to solve this equation, giving your answer correct to 2 decimal places. Alright, so for this kind of question, generally before I try to solve it, I will tend to group all the power x to one side, all the pure number, all the numbers to the other side, which means that first I try to separate all the integers first, where I'm having to multiply with 3 power 2x, I will have still 3 power 2x multiplied with 3 power negative 1. So 3 power negative 1 will become 1 over 3. And it is actually equals to 4x plus 1, where I will rewrite it become 4x multiplied with 4 power 1. Okay, and then after that, for the next step, what I'm going to do is, for this one, 3 power 2x, I can rewrite it become 3 square, and then the x outside, and it will become 9 power x. Therefore, if I rephrase it again, for this step, I'm having 2 over 3. I group all the numbers together, and then the 3 power 2x, I'm having 9 power x equals to 4x multiplied with 4 power 1. So now I separate all the numbers already from the integers, and I will start to group all the numbers with the power x to one side. So if let's say I'm moving this 4 over here, I'm having 9 over 4 power x, where I take out the x as the power, and then 4 remain, 3 and 2 multiplied to the other side, so I'm having 6. Okay, so to get the value for x, I'm going to take ln both sides, or maybe the log both sides. So I'm having ln 9 over 4, and the power x can be put in front, and I'm having ln 6 on the right hand side. And from here, you can get the value for x by bringing the ln 9 over 4 to the right. So if you press the calculator and didn't do any careless mistake, we should get 2.21 as a final answer, correct to 2 decimal places. Okay, so this is how we solve question number 1. Okay, so question number 2, they want us to expand this bracket in ascending power of x up to and including the terms in x power 4, simplifying the coefficients. Alright, so basically this is binomial expansion. And then for binomial expansion, we can apply the formula for the binomial series, where it is provided in the formula booklet. So under the formula booklet MF19, you can see that this is the binomial series formula that we can apply. Okay, where n is rational. Okay, so we come back to the question here. So we are going to apply this formula. Alright, so I try to copy it here. Alright, so you can see that before you apply the formula, right, we have to make sure that the first term in the bracket should be a 1. But our bracket, the first term is a 2. Therefore, before we apply the formula correctly, we have to factorize out the 2 first. Okay, so we have to take out the value 2, and then followed by the power negative 2. When I take out the 2 with the power negative 2, inside the bracket, I'm having 1 for the first term, and the second term, it becomes x squared over 2 and power negative 2. Alright, so now this is my bracket for the binomial expansion series, and then the first term starts with 1. Okay, our second term here is actually negative x squared over 2. So we are going to apply this formula now. And if you compare, you can see that n is equal to negative 2. Alright, so when I apply the formula, I try to simplify the first term here first. I mean the number that we factorize out, it should be 1 over 4. And after that, I start applying the formula given by the binomial series. The first term is a 1, so I just copy it as a 1. The second term is nx, so for the nx, right, I'm having negative 2, which is the power of n, power which is n, and also the x is the second term in the bracket, which is negative x squared over 2 for our case. Alright, so the third term, for the third term, I'm having n and n minus 1. My n is negative 2, n minus 1 will be negative 3, divided by 2 factorial, and the x power 2. So for my case here, the x power 2, the x is actually negative x squared over 2. So I'm having negative x squared over 2 power 2. Okay, so if I try to observe this term, when I'm having x squared power 2 outside, eventually when I simplify, I'll get x power 4. So that means I should stop my binomial expansion here. Alright, so now by trying to simplify all the terms into numbers, I'm having 1, then plus x squared plus 3 over 4 x power 4. Okay, and of course I multiply in the 1 over 4, and what are the terms that I get is 1 over 4 plus 1 over 4 x squared plus 3 over 16 x power 4. So basically this is the answer that I get. So we just need to expand the first three terms because the third term already include the x power 4. Alright, so this is what we have for question number 2, part A. And now we can proceed to part B. Alright, so what do we have here at part B? Okay, so for part B, they're asking us to state the value of x for which the expansion is valid, the values of x so that the expansion is valid. Alright, so generally if you have a look for the formula here, this is the valid value for x, which is provided in the formula booklet. And you can see that the modulus x is smaller than 1. So how we get the modulus x smaller than 1? Basically is from here, from the bracket. So we are taking the term at the back, okay, the variable at the back, smaller, the modulus of the variable smaller or equals to the number in front. If we apply it to our expansion here, generally what do we have here should be, you can have a look for the original bracket. So generally we are having modulus x squared smaller than 2. Alright, so to write the valid value for x, in this question, we should have modulus x squared smaller than 2, and we can further simplify it where it will become modulus x smaller than square root 2. And of course, we will ignore all the negative sign when we try to take the square root for this case because modulus should be always take a positive value. Alright, so this is the valid value for x for this expansion. Okay, so question number 3. They want us to solve this equation where it involves 2 cotangent 2x plus 3 cotangent x equals to 5. Alright, so generally for cotangent 2x and cotangent x, we can change it become the basic trigo where I'm having 2 over tangent 2x and then plus 3 over tangent x, and it is equals to 5. Okay, so for this question, for this equation, generally when we want to solve it, right, we have to try to express everything here into either the same trigo or either into the same the trigo with the same angle. As an example, like we're having tangent to x here, if possible, we will want to change everything here, become tangent x. Alright, so for tangent to x, it belongs to double angle formula, and we can try to expand it by using double angle formula. So it is also provided in the formula booklet MF 19. Under the trigonometry part, you can see that this is the double angle formula for tangent to A. Alright. Okay, so we can use this formula to expand it in our solution here. Alright, so again, I try to copy this equation over this part. Okay, so this is a formula that we can apply. And to apply under our solution here, it is upside down. That means the denominator become numerator and the numerator become denominator, where I'm having 2. So maybe for this one, the 2 here, I make it as a constant outside first. So 1 over tangent 2x, when I try to expand it, it will be upside down for this equation. This expression where I'm having 1 minus tangent square a or tangent square x for our case, divided by 2 tangent x. And then plus 3 over tangent x equals to 5. Alright, so from here you can try to observe that I can cancel off the 2. And now I want to make the tangent x disappear as a denominator. Therefore, I multiply the whole equation with tangent x. If I multiply the whole equation with tangent x, I'm having 1 minus tangent square x, then plus 3, and equals to 5 tangent x. right? So if I try to rephrase this equation, I will get a quadratic form equation in terms of tangent x, where it should look something like this. Okay, so to get the value for tangent x, you can apply like the quadratic formula, and you try to get the two value for the tangent x here. Okay, so the first value that I get is by using the quadratic formula, because this equation cannot be factorized. So by using the quadratic formula, I will have this value 0.70156 and also for the tangent x, I'm having this value. Okay, so this is the two value for the tangent x, and to get the value for x, I have to take tangent inverse. All right, so for tangent inverse, for this case, right, basically it is the reference angle or the basic angle, where it should be the value 35.1. So this is the basic angle, and it is also in the first quadrant because tangent is positive in the first quadrant, right? So therefore, I will take the answer basic angle as an answer from the first quadrant, which is 35.1. And to get this value, we need to find the basic angle first without pressing the negative sign. All right, so the basic angle for this case, uh, if I'm not mistaken, right, okay, the basic angle that we get for this question should be 80.1, correct to one decimal place. And because of tangent is negative, we are looking for the tangent negative quadrant. So according to the range given here, we should consider only the first two quadrants, and the quadrant for tangent negative is only the second quadrant, where we should take 180 minus the basic angle to get the answer. So if I take 180 to minus the answer here, the value that I get should be 99.9 degree. So these are the two values of x that we can solve because we solve it from the equation mentioned here. All right, so we should have two answers for the x, where the first value for x should be 35.1, and also the second value for x should be 99.9. Okay, so this is how we solve question number 4. We are having the differential equation as shown here, and then they give us information, right, y equals to 2 when x equals to 0. So they want us to solve the differential equation, obtain a simplified version for y in terms of x. All right, so for first step, when you want to solve the differential equation, you have to separate all the variables first. So you group all the y at one side, all the x at one side. So from this differential equation, I will want to keep my dy and also the y on the left. So when I want to keep my dy and y on the left, I'm having 1 over y. So that means the y, I bring it over, it becomes 1 over y. So I'm having dy here. And then for the dx, for this dx, we'll bring it over to the right hand side, and my equation will have something like x over 1 plus x squared dx. Okay, so you can see very clearly that we separate the variable y to the left and also all the variable x to the right. And after we separate all the variable, we can start to put the integration sign. We have to integrate both sides to solve this differential equation. All right, so when I want to integrate 1 over y, very straightforward, I will get ln y. And it is equals to, when I want to differentiate this one, generally you have to we have to think about the technique that we can integrate this fraction. So if you try to observe it, right, generally this is a fraction, and I will figure out that, oh, maybe for the denominator, if I let it equals to 1 plus x squared equals to fx, and if I try to find out the f prime x, it will be 2x. And which means that the 2x, now you can see the x is appear on the numerator, and I can actually treat this equation, this expression as the the integration for f prime x over fx pattern. So to make the numerator become f prime x, I can multiply it by 2. And to make it balance, outside I will divide it by a 2. So that this expression, this side of the equation is still balanced. Alright, it is not changed, although we already changed the numerator become the f prime x. Alright, so now we are having exactly the f prime x over fx pattern in our integration here. So when we try to integrate it, we will have ln and then 1 plus x squared. Okay, then have a plus c here. Alright, okay, so we already integrate the equation, and now we need to find out the value for c. So how to find out the value for c? We have to use the information given by the question. When x equals to 0, y equals to 2. So when x equals to 0, you have to substitute 0 into the equation that you get, and also y equals to 2. And what do we have here? So ln y become ln 2 equals to half ln 1 plus c. So the ln 1 here is a 0, therefore you can see that the c is equals to ln 2. Alright, so very easily from here I can get the value for c. So I rewrite my equation again. Ln y equals to half ln 1 plus x squared plus ln 2, which is the c. And because of for this question, they want us to express our answer y in terms of x. So to express it, first, my direction is I try to group both left hand side with only one ln and also the right hand side with only one ln. So left hand side here already have one ln only, so I didn't touch it yet. Okay, so for the right hand side, I will want to try to group all the terms together become one ln only. So for the power half, I try to move it back. So for the power half here, I try to move it back. So we're having something with power half. It is actually a square root. So I'm having square root 1 plus x squared. And then plus ln 2. Okay, and after that, for this one, ln square root 1 plus x squared plus ln 2, you can combine it, become ln 2 multiply with 1 plus x squared. And for this one, we are actually using the idea that ln pq equals to ln p plus ln q. And now we are doing it backward. Okay, so this one is something like ln p plus ln q. When you do it backward, it become multiply. So ln 2 square root 1 plus x squared. So when both sides have only one ln, you can cancel them, left and right hand side. Therefore, the y is actually equals to 2 and then square root 1 plus x squared. So this is how we solve this differential equation for question number 4. Question number 5. We have a polynomial, and then a and b are constant denoted by px. So this is a polynomial px. It is given that x minus 2 is a factor for both px and also p prime x. Alright, so find the values of a and b. Okay, so now we know that x minus 2 is a factor, which means that x equals to 2 is a root, okay, for this whole equation. Alright, so when having px, right, okay, if x minus 2 is a factor for this polynomial, that means if I substitute 2 into the equation p, I will have no remainder, which means that it is equals to 0. Alright, so I want to substitute 2 into the x in the polynomial p, and we will get one equation. So 2 power 3, you get an 8. So you're having 8a minus 4 times 10, you get a 40, plus 2b plus 8, and it is equals to 0 because of no remainder. Alright, then if I try to simplify everything here, I will have equals to 32. 8a plus 2b equals to 32. And can further simplify again, I'm having 4a plus b, which is equals to 16. And this will be my first equation here. Alright, okay, so I need another equation so that I can solve simultaneously to get the value for a and b. And now we have another information where they tell us that x minus 2 is also a factor for p prime x. Okay, so first of all, maybe it will be good if you can find out the p prime x first, the differentiation for the polynomial. So when we differentiate this one, I'm having 3a x squared. Differentiate the second term, I'm having negative 20x. And differentiate the third term, I'm having plus b. So the fourth term is a constant. So after I differentiate, it becomes 0. All right, so this is my p prime x. And again, because x minus 2 is also the factor for p prime x, therefore we apply the factor theorem here, which means that when we substitute 2 into the polynomial, it will be equals to 0 because there's no remainder. So now I'm substituting the 2 into x for the p prime x. All right, so I'm having 2 squared is 4, 4 times 3 is 12, so 12a minus 4d plus b, and it is equals to 0. So from here, I get my second equation. All right, then to get the value for a and b, we can just solve the simultaneous equation. All right, so for me, I'm taking equation number 2 minus equation number 1. If I take equation number 2 minus equation number 1, I'm having 8a equals to 32, oh sorry, 24. Okay, so from here, I get the value for a, which is equals to 3, and this is my answer for the a. And now substitute back the a into either equation 1 or 2, either one. And from that, you will get the value for b, which is equals to 4. So a equals to 3, b equals to 4 for the answer of part A. Right? Okay, so now we can proceed to part B. So for part B of question number 5, they want us to factorize the px completely. Alright, so to factorize the px completely, generally there are a few methods that you can apply. So for me, I'm using a long division. Okay, so for long division, I will have the original polynomial p. So the original polynomial p will be, a is a 3, right? So it will become 3x power 3 minus 10x squared. And then the bx will be, b is 4, so 4x plus 8. And the factor is x minus 2. Okay, so from here, I try to um, apply the long division. Okay, so for the first term here, it will be 3x squared. Because 3x squared multiplied with x, I get 3x power 3. And 3x squared multiplied with negative 2, I'm having negative 6x squared. Alright, then you take negative 10x squared minus negative 6x squared, you have negative 4x squared, and plus 4x. You pull out the 4x here. And then now I'm going to multiply it with negative 4x, so that negative 4x multiplied with x, I get negative 4x squared. Then the same thing happens for the second term. I'm having 8x. Then you minus again from the term above minus the bottom term, you're having negative 4x plus 8. So I'm having negative 4 for this case. Alright, so you can see that we don't have any remainder for this long division, which is correct because we shouldn't have any remainder if the polynomial is divided by the factor. Alright, so since we already know that this is the quotient and this is the divisor, right? Therefore, for px, it can be expressed as divisor of the factor multiplied with the quotient. And there's no remainder at the back, there's no plus remainder because the remainder is equal to 0. And now you can further simplify this polynomial. So to simplify it, x minus 2 is actually the original factor that we have. And then we can try to factorize out the quotient. So to factorize the quotient, I'm having 3x multiplied with x, and then 2 and 2. So they want a 4, which is negative 2 and plus. Okay, and oh, you realize that x minus 2 and x minus 2 are same. So you can rephrase it again, become x minus 2 squared, and then 3x plus 2. Okay, so this is how we factorize the px completely for question number 5. Okay, so let's discuss question number 6 now. Okay, we are having this I equals to this expression. And then for part A, by using the substitution x equals to 3 tangent x, they want us to show that I also can be written as this expression. Okay, so the very obvious technique that they want us to use is the substitution method for the integration. Okay, so for substitution method, generally we'll start from the substitution equation that they give us first. So we are having x equals to 3 tangent theta. Okay, so first step, we try to find the differentiation for x towards theta. So 3 is a constant, I just copy, and then differentiate tangent theta, I'm having secant square theta. Alright, so I can rephrase it again where dx is equals to 3 secant square theta d theta. Okay, so this is the first part that you need to complete. And then after that, we also need to try to change the value for the limit, where all these values here are for the value of x. And we need to change it become theta. Alright, so that means that when I'm having x equals to 0, when the limit x is equals to 0, what happened to the theta? So the theta is equals to, okay, we can get the theta from this equation that they want us to use. Alright, so for this theta, if I try to rephrase it, it is actually equals to theta equals to tangent inverse x over 3. Okay, so you try to use it here to find out the theta. Alright, so now x is equals to 0. So tangent inverse 0, you will get a 0 here. Okay, and then for the next limit, when I'm having x equals to 3, this is a 3, right? Okay, so when x equals to 3, what happened to the theta? So again, to get the value for theta, you substitute the 3 into this equation. So it is tangent inverse 1. So for tangent inverse 1, you get the theta equals to pi over 4. Alright, so once we change the value for the limit and also we try to differentiate the x towards d theta, we can start to replace all our variable x into the theta. Alright, so this is what we have originally. I'm having 0 and 3, and then we are having 27, and then 9 plus x square dx. Okay, so first of all, I want to replace the limit first. So 0 to 3 will become 0 to pi over 4. 27, it is still a 27, it will not change. And then for the denominator, I'm having now 9 plus 9 tangent square theta, and then I square it again outside. And for the dx here, I will replace it by using this one, where I will have 3 secant square theta d theta. Alright, so again, this whole thing is actually the dx. Right, this is the dx, right? So dx is equals to this one. So we replace it here. Okay, so generally we have tried to replace everything by theta already. And now we have to slowly rephrase it again or simplify it to get the expression that they want. Okay, so I try to simplify the denominator. Okay, so for the numerator, I will take 27 multiply with 3. So 27 multiplied with 3, I will get 81 as a numerator. And then the secant square theta, I will put it as numerator also. Then the theta, I just put it at the back. Okay, so for the denominator, right, I will factorize out the 9 and I get 1 plus tangent square theta and then square outside. Okay, so next step. For the numerator, I will not touch it. For the denominator, when I have 9 square is 81. 1 plus tangent x square, right? 1 plus tangent x square is secant square theta. and then I still have a square outside. Okay, so from here to this part, I'm applying the identity formula. All right, the Pythagoras identity. All right, so 1 plus tangent x square theta will be equals to secant square. So now I can further simplify it now. 81 can be simplified with 81. And then the numerator and denominator, right, I can cancel off the secant square for the numerator. And you can see that we are having 1 over secant square theta. So 1 over secant square theta, generally it means that 1 over 1 over cos, and you are having cos square theta. Okay, so this is how we actually get the equation or expression that they want us to show. All right, okay, then now we can proceed to part B. Okay, so for part B, they want us to find the exact value of I. So to find the exact value of I, right, you have to apply the integration for pi over 4, 0, then cos square theta. Okay, so to integrate cos square theta, I have to change it become a trigo function that's without the square. All right, so we can consider to use the identity double angle formula. All right, the double angle formula, I'm having cos 2 theta. Okay, it is equals to 2 cos square theta minus 1. So if I rephrase it, I'm having cos square theta, it will be equals to cos 2 theta plus 1 divided by 2. So this is the double angle formula that is provided in the formula booklet as well. All right. And now I want to replace the cos square theta by using this identity, this formula or this expression before I can integrate it. All right. So I will start here. All right. So for this expression, I shall always replace it. So 1 over 2, then cos 2 theta plus 1 d theta. All right, then because the 1 over 2 is a constant, so for my practice, I prefer to take it out before I integrate anything. Okay, so cos 2 theta is a simple trigo function, and I can actually integrate it straight away. So integrate cos, I will have sine 2 theta and divided by 2. The differentiation of 2 theta, you get a 2, right? So you divide it by the 2. And then integrate 1, you get a theta. And after that, of course, I need to substitute the limit into the integration term. Okay, so half is still a half. Right, substitute pi over 4 into the sine 2 theta, I'm having sine pi over 2. Sine pi over 2 is a 1. So I'm having 1 over 2. Substitute pi over 4 into the theta, I'm having pi over 4. So I will just keep it as pi over 4 because for this question, they want us to get the exact answer. Alright, so I just keep it as a fraction pi over 4. Then minus, now I want to substitute 0 into the expression here. If I substitute 0 into here, I'm having 0 plus 0. All right, so we can try to simplify it, multiply in the half into the answer, and having 1 over 4 plus pi over 8. And this is the exact answer for the integration, okay, for this part. All right, so don't change it become decimal number because the question requests for exact value. Okay, so this is how we solve question number. All right, so question number 7. Okay, so we are having a complex number u, and it is defined by something like this. All right, and where a is a positive integer. Okay, so they want us to express u in terms of a in the form of x plus yi, where x and y are real and exact. All right, so they want us to express this in exact form for the u. Okay, generally we need to rationalize it because of the denominator we are having something with the I. All right, so therefore to rephrase u into x plus yi, we need to apply rationalization where we have to multiply the conjugate of the denominator. All right, so I'm having the numerator as usual, as what they give us, and then divided by 1 plus 2i. So the conjugate for 1 plus 2i is actually 1 minus 2i, and we need to multiply that. So divided by 1 minus 2i. All right, so this is what we call it as a rationalization. Okay, so we try to simplify it. For the denominator, if we try to expand it, we are having 1, and then plus 2i minus 2i we cancel off, and 2i multiplied with 2i you are having 4i squared. So negative 4i squared it will become plus 4. Okay, so for the numerator on top, as usual, you need to expand terms by terms. All right, expand first term with the first and second term, and also this one. Okay, so you try to expand it, we will have square root 2, then minus 2 square root 2i, minus a square root 2i, and also this one, a square root 2i multiplied with 2i, we are having 2a square root 2i squared. And eventually, if we try to simplify, I'm having negative 2 square root 2a. So just to recall that, okay, I squared is actually equals to negative 1, right? Okay, so from here, we try to simplify our answer. 1 plus 4 is a 5, and I try to group all the real part with the real part, like real number with real number. So square root 2, I will compile it together with negative 2 square root 2a. Negative 2 square root 2a. And for this term, I will take out the negative and also the I. And what I will have here is 2 square root 2 plus a square root 2 I. Okay, so if I separate it into real with the real part, imaginary with imaginary part, what I will have here will be something like this. I'm having square root 2 over 5, and then 1 minus 2a. This is the real part, okay? I factorize out the square root 2 and also the 5, and therefore this become 1 minus 2a. And for the imaginary part, I also try to take out the square root 2, and I'm having 2 plus a and I. So this is u in terms of x plus yi. Okay, so we proceed to part number B. Okay, so for part number B, they are now saying that given that a equals to 3. So when a equals to 3, we try to substitute a into our equation here. All right, so you can substitute 1 minus 2 times 3, which is negative 5. All right, so negative 5 divided by 5, you have negative square root 2. And then substitute a here also, you have negative square root 2i. Okay, so we try to substitute the value a into the u. Right, so when I try to substitute it, my u is equals to negative square root 2 minus square root 2i. Okay, so they want us to express the u in the form of r e power I theta. So again, for the I here, it should be the modulus of the u, and the r here, sorry, the theta here will be actually the argument of the complex number u. Okay, and they want us to give also the exact value for the r and also theta. All right, so once I get the complex number u already, then I will try to find out the modulus for u. So the modulus for u will be the square root of real part square, so negative square root 2 square plus the imaginary part also square. Right, so from here I will get actually a 2, and I want to get the argument of u. So to get the argument of u, for this complex number, it is actually in the third quadrant. So for the third quadrant means it will be somewhere here. So when we measure the argument, right, it should be negative angle. And also in this quadrant, the formula should be negative pi minus the reference angle. Okay, so generally to get the argument u, I'm having negative and then pi minus the reference angle or the basic angle. So for the basic angle, it will be tangent inverse square root 2 over square root 2. So tangent inverse square root 2 over square root 2 will be equal to pi over 4. So you're having negative pi minus pi over 4. So when you simplify the equation or simplify the answer, right, you should get negative 3 pi over 4. All right. So please take note that this is actually the R. R is equals to the modulus of U, and also the theta is equals to the argument of U. Okay, so if we rewrite it into the form of the into the exponential form, we are having U equals to 2 and then E power negative 3 pi over 4i. Okay, so this is the exponential form of the U, and it is in terms of exact value. All right. Okay, so this is what we have for part B. And now we proceed to part C. So for part C, we want to use our result in part B. Okay, find the square roots, 2 square roots of U. And after that, our answer also in the exponential form. Okay, so we are looking for the square roots, and then must be also in the exponential form, and also the final answer should be in the exact values. All right, okay, so since the U here is equals to 2, E negative 3 pi over 4i. Okay, so to find the square root of U, okay, so first of all, we can straight away find out the modulus of the square root U. So if I want to get the square root U, right, the modulus of the square root U will be equals to square root of the modulus U, where the modulus U equals to 2 in part number B. Therefore, I'm having square root 2. So this is actually the modulus of the square root U. And after that, I want to get the argument of square root U. So for the argument of square root U, we will be having two values, two different answers. Okay, so to get the argument of square root U, basically the first answer will be half. Okay, half of the argument U. So the argument U is negative 3 pi over 4. So I multiply with 3 pi over 4. So this is the first square root, the argument for the first square root. And the answer for the second square root, right? To get the argument, generally it depends on the answer for this part. So if the first answer here is a negative angle, then the second square root will be actually in the positive angle. All right. So when the second answer, the argument will be in the positive angle, means that we have to add back. We have to add back pi. Okay, which is the half round. All right, or 180 degree. Okay, to make it become positive, to get the argument of a square root. So for the first value here, we are having negative 3 pi over 4 divided by 2, and we get negative 3 pi over 8. For the second answer here, it will be negative 3 pi over 8, and we add back the pi so that we can get a positive value for the square root here. And then the positive argument for this square root will be 5 pi over 8. All right, so we are having this, the square root of U is having actually the same modulus, and they are having two different arguments. All right, so the square root of U, we can rewrite it become, first answer will be square root 2, and then E power negative 3 pi over 8i. And another one will be square root 2 E power positive. All right, so 5 pi over 8i. All right, so this is actually the answer for the square root U in the exponential form. Okay, so we come to question number 8. All right, so we are having a equation given like this, and then they want us to find dy dx in terms of x and also y. All right, so we can see that for this equation, right, x and y are not separable. Therefore, we can apply the implicit differentiation. So apply the implicit differentiation for the first term, x power 3. When we differentiate, we will have 3x squared, and then dx. Then plus second term, y power 3. It will be 3y power 2. And then because of this is with respect to, this is a variable y, right? So we will differentiate it with respect to x. We will need to put dy dx at the back. Then plus, okay, x multiply y we will treat as a product, okay? So we have to apply product rule at this part. All right, so x is the first bracket, y is the second bracket. Okay, so when I differentiate the x, I will get a 1, so I just copy the y. And now I copy the first bracket x, I differentiate the y. So differentiate the y, I get a 1. And of course, after I differentiate the 1, I have to put dy dx here. Okay, 8 is a constant. When I differentiate, it will become a 0. And it is equals to 0 for this whole equation. Alright, so now I try to reverse everything by trying to group the dx dy at one side and also all the other variable on the other side. Okay, so first of all, I try to take out, maybe I will try to group the dy dx on the right, on the left. So dy dx will be 3y squared plus 2x, and it is equals to negative of all the other terms are 3x squared plus 2y. Okay, so if I try to move the bracket to the right hand side, and hence I will get a dy dx here. Okay, so my dy dx should look something like this. And then if we double check, we realize that it cannot be simplified anymore. So this will be the answer for our dy dx. Okay, so for this question, we are applying implicit differentiation. Alright, then now we proceed to part B. Okay, so for part B, they are saying that the tangent to the curve at the point where x equals to 0 and also the tangent at the point where y equals to 0 intersect at the acute angle alpha. And they want us to find the exact value for tangent alpha. Okay, so please take note that when we are talking about the tangent to the curve, so tangent to the curve means that it is dy dx. Alright, so just to recall back, for this question, right, the original equation is x power 3 plus y power 3 plus 2xy plus 8 equals to 0. This is our original equation. And just now in part A, our dy dx is actually negative 3x squared plus 2y divided by 3y squared plus 2x. So these are the two important information that we are going to use it here also. Alright, so when they say tangent to the curve means dy dx, and also when x equals to 0, that means there's a certain point, right? On a certain point. We want to get the dy dx at this certain point here. Alright, so when x equals to 0, we need to know what is the value for y when x equals to 0. Therefore, we have to substitute back into the original equation here. Substitute x equals to 0 into the original equation. We are having actually y power 3 plus 8 equals to 0. Okay, when x is equals to 0. And for the value of y that I get here would be negative 2. Alright, so that means we are having the coordinate 0 and negative 2. And what is the dy dx value when x equals to 0 and y equals to negative 2? So we try to substitute into dy dx here. Substitute x as a 0, substitute y as negative 2. And if we try to simplify it, we will get the value. Okay, so let's try. We are having negative and then negative 4. So we're having negative and negative 4 on top divided by negative 2 squared, which is the 4. 4 times 3 is a 12. So we have a value 1 over 3 in this case. This is the dy dx when x equals to 0 and y equals to negative 2. And now we are having the second point. We are having the y equals to 0 and we want to know what is the value of x and also what is the dy dx at this particular point here. Right? So again, substitute the y equals to 0 into our original equation, and from there we get, okay, so when y equals to 0, I will get the equation x power 3 plus 8 equals to 0. So from here I get the point where x equals to negative 2. Okay, so this coordinate will be actually negative 2 and 0, and I want to find out the dy dx at this particular point. So again, we try to substitute x equals to negative 2 into the equation here. So 4 times 3 got a 12. So I'm having a negative 12 on top divided by y equals to 0, x equals to negative 2, right? So negative 2 times 2, you get a negative 4. And our dy dx will be equals to 3. Okay, so they are saying that these two tangents intersect at the acute angle alpha. Okay, so generally when we want to find out the uh, angle between two straight lines, because both tangents are straight lines, right? So to find the angle between two straight lines, generally the formula is tangent inverse, tangent alpha should be equals to m1 minus m2 or m2 minus m1 divided by 1 plus m1 and m2. And please take note that the m1, m2 here, right, generally means the gradient of the tangent. So we are having the gradient of tangent 1 over 3 and 3. So you can treat any one of it as m1, any one of it as m2 lah. Okay, so you can make it as, maybe you can put the larger value as m1 and then the smaller value as m2. And let us have a look what are we going to get. All right, okay, so m1 will be 3 minus m2, which is 1 over 3, then divided by 1 plus m1, m2. Okay, so when I try to simplify this fraction, I will have 4 over 3 as the answer. Okay, where this is the correct answer. We shouldn't get a negative value here. You should get a positive value. Therefore, I try to put the m1 as a bigger gradient, m2 as a smaller gradient. So why the value here must be a positive value? The reason is because of they already told us earlier that alpha is actually the acute angle. All right, so when alpha is acute angle, all the acute angle will be positive right in the first quadrant. Should be in the first quadrant, right? And then everything should be positive. So tangent alpha, we want to make sure that we are getting a positive value. Therefore, we have to set the larger the m1 as a greater as the larger gradient. Therefore, you put it as a 3. If you put 1 over 3 here minus 3, you get a negative value where it will not be a acute angle. All right. Therefore, there's a small setting here. You have to make the m1 as a greater gradient and minus the smaller gradient to get a positive value of 4 over 3. All right, so question number 9. They give us a diagram and then they tell us all the important parts, important information about the diagram. So we know that OA is equals to 2 units and then OC is 4 and also OG is 2 units. Okay, so the unit vectors IJK are parallel to OA, OC, and OG respectively. So you can see that all the all the direction are labeled clearly. The point M is the midpoint of DF. So this is the midpoint of DF. And also the point N on AB is such that AN equals to 3MB. So from here, we should know that from A to N, this length might be a 3 units. Okay, so 3 unit, and this is actually 1 unit. All right, so for this particular question, generally what they want us to find is they want us to express the vector OM and also the MN in terms of IJ and K. All right, so let's start with OM first. So to find OM, there are many pathways that you can get the OM. So start from O, there are many ways that you can travel to M. Okay, so maybe for me, what I did is like, I will try to move the O. I will try moving my O to A first. So from O to A, it is 2 units of the I direction. So I'm having 2I. After that, I'm trying to move the A from A to the center of AB. So when I try to move A to the center of the AB is in the J direction and we are walking 2 units. Therefore, it will be plus 2J. From the center, I try to move up, okay, to the direction where it is parallel to the K. All right, and also this direction is 2 units as well. So I'm having plus 2K. And after that, I need to move backward, okay, to get the M. So to move backward to get the M, generally the direction is the opposite direction of I. Therefore, it should have a negative I direction, and the unit that we walk is 1 unit back. All right, so it will be minus 1I. Okay, therefore, after I reach the M already, I try to simplify my answer here. So 2I minus I get an I. then plus 2j plus 2k. So this is the OM that we have. Right, so after that, they want us to find out MN. Okay, so to get the MN again, generally we need to go through all the possible pathway to get the vector of MN. Alright, so if I want to get MN, generally I will start from the point M and move to point N. This is the M. Okay, so there are many ways also that we can move. Alright, so for me, I will move M to this direction first, where this is the direction of I. So I'm moving 1 unit of I, so I'm having 1 I. After that, I'm going to move down vertically. So to move down vertically, it is 2 units here, and it is in the opposite direction of K. Therefore, I'm having negative 2K. And I'm moving from center to the end. So from center to the end, it is in J direction, and I'm moving 1 unit here. Therefore, it will be plus J. So if I rephrase it again nicely into the form of I, J, and K, it will be 1I plus 1J and minus 2K. So this is the vector of OM and also the vector of MN. Okay, then now we'll proceed to part B. Okay, so for part B, they want us to find a vector equation for the line M, through M and also N. So again, if we try to imagine my M is here and also the N is here, to form the vector equation, we need two information. The first one will be the passing point. So for passing point, right, we need either the position vector of M or position vector of N. For us, right, we already have the position vector for M. OM is actually equals to the OM that we get here. After that, to get the vector equation, the second information I need is the direction of the line. So the direction of the line here can be MN or can be NN. So again, the direction of the line, I also get it from part 1 already, which is this. This is the direction of the line. Okay, therefore we can write out the vector equation very easily by using the answer that we get on part A, from part A. So the vector equation, I will rewrite it like this. R is actually equals to OM. So OM is 1, 2, 2 plus TP. So the P will be the direction of the line. So the direction of the line for us, I'm using MN here. So MN will be 1, 1, and also negative 2. So this is the vector equation for the line MN. Okay, then now let's proceed to the third part, part C. Alright, so for part C, in this question, right, they want us to show that the length of the perpendicular from O to the line through M and N is square root 53/6. So you have a look here, O is here, MS is something like this. Okay, so if I try to redraw it again, okay, we try to visualize it a little bit. Okay, so I'm having M here, so N is here. And let's say the point O is here. I'm trying to find out the direction, the perpendicular distance from O to this point, to the line MN. All right, so the perpendicular distance should be this one. Okay, so maybe I will label this as a point Q, the foot of perpendicular as point Q. Okay, so just to clarify, the perpendicular distance from O to the line will be the modulus of OQ. Okay, so first of all, I want to find out the position vector for Q, which is OQ. I want to find the OQ first. Since the Q lies on the line MN, therefore the position vector for Q will be actually the vector equation for the line MN. Alright, so for the line MN just now, vector equation, I'm using the variable t. So maybe to differentiate this, which is a point on the line, I'm using it as a lambda. So which means that according to the answer here, okay, so this is actually the vector equation for the line MN, right? So to get the position vector for Q, we will change the D become a lambda, where this lambda is specifically for the point Q on the line. So if I try to rewrite again, I'm having 1 plus lambda, 2 plus lambda, and also 2 minus 2 lambda. And this is our OQ in part C. Okay, all right, because for any single point on the line, right, on the vector equation, any single value for T on the vector equation, it represents a point on the line. Therefore, OQ is also a point on the line, correct or not? Therefore, I will just denote the T by using the lambda. Okay, so I will proceed back to the part C here. Okay, so just now we already know that our vector equation, our position vector for Q will be actually equals to 1 plus lambda, 2 plus lambda, and also 2 minus 2 lambda. Okay, so to get the modulus of OQ, right, at first I need to know the lambda first. So how can we find the lambda? Okay, so from here, we know that the direction of OQ and OMN are actually perpendicular to each other. So by using the result where OQ dot product with MN, it should be equals to 0. It is because of they are perpendicular to each other. Position vector for OQ will be 1 plus lambda, 2 plus lambda, and also 2 minus 2 lambda. The direction of MN, we already get it in the first part just now, where it is 1, 1, and negative 2. And we let it equals to 0. So for this case, we are applying the dot product, where we take the component I multiply with component I, which is 1 plus lambda. Component J multiply with component J, where I'm having 2 plus lambda. And the component K multiply with component K, I'm having negative 2 multiply with 2 minus 2 lambda. And it is equals to 0. So from here, if we try to simplify this equation, I'm having negative 1 plus 6 lambda equals to 0, where the lambda, I'll get a value, it is 1 over 6. Okay, so once we get the lambda, which is the value, with the value 1 over 6, we can continue, okay, to substitute into the OQ vector. So substitute into the OQ vector, what is the vector, position vector for the point Q? If I substitute lambda equals to 1 over 6, okay, so if I substitute, I will have OQ equals to, substitute here, right? So I'm having 7 over 6, and then 13 over 6, and also 5 over 3. Okay, so since I already know that Q has a position vector for this one, and therefore to get the perpendicular distance, I need to find the modulus of OQ. To find the modulus of OQ, it is actually the x squared plus y squared plus z squared. So by using calculator, right, we just try to expand everything. Okay, so I'm having 49 over 36, 169 over 36 also, and then 25 over 9. Okay, if I add all the answer together, I will get 53 over 6, which is what they want us to show. Okay, so this is how we try to find out the perpendicular distance, okay, from O to the line MN. Okay, so now let us discuss question number 10. Okay, so they give us a diagram and telling us that for this diagram, we are having the curve y equals to x square root sine x, and then they are having one stationary point in the interval 0 to pi, and then the stationary point is at x equals to a. All right, so they want us to show that the tangent a is equals to negative half a. Okay, so to show this question, generally we will need to start from the information where we are having the stationary point at x equals to a. Okay, so let's try how to find out the stationary point. So to find the stationary point, basically we need to apply differentiation. So we are having y equals to x and then sine x power half. So we can say that this is actually the product of two functions, all right? So to find the differentiation, we actually have to apply a product rule. Okay, so first we try to differentiate the first bracket first. Differentiate the x, I get a 1. and then I copy the second bracket. Second bracket, it is actually sine x power half. Plus, and now I try to copy the first bracket, which is the x, and I differentiate the second bracket. So to differentiate the second bracket, I bring the half in front, copy the bracket, power minus 1 become negative half. And after that, I need to differentiate the thing inside this bracket here. Differentiate sine x, I will have cos x. Okay, then at the stationary point, we'll actually let the dy dx equals to 0. And we can try to simplify this equation. Right, so if we want to simplify this equation, generally what I'm not going to do is that I will factorize out the square root sine x, should be 1 over square root sine x. When I try to factorize out the 1 over square root sine x, right, for this term, first term, it will become sine x, so that you can try multiply in back, you will get the square root sine x here. Okay, and after that, for the second term here, after I factorize out the 1 over negatives, 1 over square root sine x, I will have actually x over 2 and then cos x. Okay, and now if I try to solve this equation, I'm having 1 over square root sine x equals to 0, where we will actually ignore it because there will be no, there will be a math error. All right, so 1 over sine x equals to 0, we actually ignore this answer. And then we are trying to solve for this part. So this part is actually sine x plus x over 2 cos x. It is equals to 0. Okay, then we try to move on all the answer here. So I'm having sine x equals to x over 2 negative and then cos x. Okay, so from here, right, we try to rephrase the equation so that I get something with tangent. So very obvious, if I bring the cos over, I will have tangent. So tangent x is equals to negative x over 2. And this appear, or this happens at the point x equals to a. Therefore, we can conclude that the tangent a is equals to negative a over 2. Alright, so this is how we actually get the equation that they want us to show here. Alright, okay, so this is what we have for part A. And then now let's proceed to part B. Okay, so for part B, okay, they want us to verify that the A lies between 2 and also 2.5. Alright, so our original equation in part number 1 is actually this one. We are having tangent x equals to negative half x. Okay, so to apply the sign change method, generally we need to let this equation make it become a function so that we can check for the sign change. Alright, so I will let fx equals to tangent x and then plus half x. Okay, so first I try to substitute in the value 2. So I will have tangent 2 and then plus half multiplied with 2. And I will get the value negative 1.19, correct to 3 significant figure. Okay, and then if I try to substitute 2.5 into the function, I will have tangent 2.5 plus half and then 2.5 here. Okay, when I simplify the value, I will get 0.503. Okay, so please take note that if you want to get these two values correctly, right, your calculator should be in the radian mode because all the values here, we are measuring it and in radian to get the correct answer. All right, so from here, you will get negative 1.19 and also 0.503. You can see that one value is positive, another value is negative. Therefore, we should make a reasoning and the argument to conclude it. So we are having sign change can be seen. Between these two value, right? F2 and also F2.5. Okay, and therefore we can make the argument that the A actually lies between 2 and also 2.5. So this is what we have for part number B. Okay, then now let's proceed to part C. So for part C, they want us to show that if a sequence of value in this interval given by the iteration formula, so they give us the iteration formula here, converge and it converges to alpha, the root of the equation in part A. All right, so from here, maybe I want to rephrase this iteration formula. Okay, so ignore the n plus 1 and n. So my iteration formula should look something like this. Okay, I want to rephrase it back, become the original equation that I have, where it should be tangent x equals to negative half x. So how can I rephrase it, become this pattern? All right, so generally start from here. Okay, I will have tangent inverse 1 over 2x equals to pi minus x. Okay, so I don't want to have any tangent inverse in my equation, so I will bring the tangent inverse over. So I will get something like this, where it should be half x equals to tangent pi minus x. Okay, so if I rewrite again, I will have something like this, tangent pi minus x equals to half x. All right, so if I compare with the answer that I want, right? So I should have a tangent x here, but in my solution, I'm currently at the term tangent pi minus x. So I have to further simplify it. Okay, you can use some basic knowledge on trigo, where pi minus x refer to the answer, okay, the value in the second quadrant. All right, then you assume that this is in second quadrant, therefore in second quadrant tangent will be negative. So the value should be actually tangent negative tangent x. You can straight away change it in this way, and it is equals to half x. And after that, we are having tangent x equals to negative half x. Okay, so this is one way of proving. Or some of us, we might need some more detailed steps to get tangent pi minus x become the negative x. You can apply the compound angle formula, where tangent pi minus x, we can actually write it become tangent pi minus tangent x divided by 1 plus tangent pi tangent x. Okay, and then you can see that the value, the tangent pi is actually equals to 0. So this one is equals to 0. If you try to simplify it, eventually you also get a negative tangent x. You can use this one, the compound angle formula. All right, and this is how we get from the iteration formula to get back the original equation that we have. So this is what we have for part C. Okay, then now we proceed to part number D. Okay, so for part number D, they want us to use the iteration formula given to find out the roots correct to 2 decimal places, and then our iteration should be in 4 decimal places. Okay, so we have to calculate out or find out the value. All right, so maybe let us start with x1 first. Okay, so to get the initial value, generally for this question, they didn't give us any initial value, so you can use any value that is between 2 to 2.5. So for me, myself here, I'm starting it with 2.5. All right, so the iteration formula that we are using is this one, x equals to tangent, pi. It is given in part C, right? So pi minus tangent inverse x over 2. This is my iteration formula. Okay, so to get the next value, x2, I need to substitute 2.5 into the equation, the iteration formula equation. So 2.5 over 2. If you try to press calculator for this part, we'll get 2.2455. Okay, so you can have a look here. By keying the iteration formula, you can try to key in the iteration formula where it should be pi minus tangent inverse, then x over 2. So our x will be here. This one, x divided by 2. Okay, so we calculate the value, and I want to key in the value 2.5. So when I key in the value 2.5, you can see very clearly that this is 2.2455. So this is how I get the value, 2.2455. Okay, and then to get the x3, so to get the x3, we need to do the same thing where we substitute the value 2.2455 into the equation. And what's the value that we get? So again, we press the calculate again for the calculator. So now we want to key in the value for 2.2455. So I put in 2.2455. So what's the value that I get now? I'm getting 2.2984. Therefore, for the next iteration, the value that I get is 2.2984. Okay, so we repeat the same thing until we get the answer with 2 decimal places, which is the same. All right. Okay, so next, calculate again. And then now I want to key in the value for x, which is 2.2984. So 2.2984. I'm getting 2.2869. Again, I will write in 2.2869. So what's the x5? Okay, so by right, if you check right, the answer for 2 decimal places are not repeated yet. Okay, so I still need to continue the iteration until I get the answer for 2 decimal places repeated. Okay, so calculate again. Calculate. And what's the value for x? Should be 2.2869. So I key in the value for x4 and I press equal sign. Now my next iteration is 2.2894. 2.2894. So if you try to observe these two iterations, right, okay, this will give you the 2 decimal places answer as 2.29, and this also will give you the same, the 2 decimal places answer, which is 2.29. If you want it to be safe, you can try for one more extra iteration to confirm the answer. Okay, so the last iteration that I want to do is again insert the 2.2894. So press on the calculate sign, and then I key in 2.2894, and I press equal sign, and I get 2.2888. Okay, so again, I will write in 2.2888, and I double check my answer if I convert it into 2 decimal places answer, and it is still 2.29. So since these 2 decimal places answer repeated already, therefore we can conclude that our answer for the A is equals to 2.29. Okay, so please take note that for this question, right, you need to make sure that all your iteration must be in 4 decimal places, and your final answer, okay, for the A or for the root should be 2 decimal places. And another thing to take note is when you try to press the calculator here, again, please have a look for the unit of the degree here. It is in the unit of radian. So to ensure that you get the correct value like what I get here. All right, so here we ended our this paper, okay, this paper 3-1. All right, so thank you very much for watching.